Okay, so let's finish up hopefully this section. A little review first. Single replacements, you will have one element and one compound. If that element is a metal, it will replace the cation in that substance. If that element is a nonmetal, it would replace the anion in that substance. So we have on the reaction side one element and one compound. And on the product side, you have a second new element and a new compound. So on each side, one element and one compound. So in this case, Cl is an anion or a nonmetal, so it is going to replace Br. And for our products, we would get Br2 and NaCl. Since chlorine is diatomic and bromine is diatomic, we will need a couple of coefficients to balance the equation, and that would be the same in any case. You need to, after writing the products, write and balance the rest of the equation. So, activity series pretty much falls in line. I will allow you to have your activity series for these kinds of questions. But the thing to remember and maybe have in your notes would be that anything that is higher on the list can replace, as an element, can replace something that is lower on the list. So iron is higher than copper, and so iron can replace copper, but copper is lower on the list and cannot replace iron. And so that will tell us whether a reaction will take place or not. The activity series, so it has to be higher to replace something that is lower. Halogens also have an activity series. Luckily for us, those are just in the order of the periodic table. So fluorine can replace anything lower than it, but bromine can only replace iodine. It cannot replace chlorine or fluorine. So since bromine in this reaction is less active than chlorine, it wouldn't replace it as in the last equation, but on the one above it, it would replace iodine. So here's like a little picture of what's happening. We know in a double replacement reaction, we're making a product that is typically insoluble or a solid. And that's what we see in that orange solid or cloudy substance that is forming. And in this case, we have two aqueous reactants that are both compounds, typically ionic. And we have two products, both are ionic, one is soluble, AQ, the KNO3, and one is not, PB2I, or PBI2, sorry. So double replacement, the cation from the first substance will now be coupled with the anion from the second substance. So we see that we have K with I here, and in my product I have K with NO3. Here I have PB with NO3, and over here I have PB with I. So it's like they are switching partners. So double displacement reactions to occur. One of the products is only slightly soluble or forms a solid in solution. One of the products is a gas, or one of the products is a molecular compound. A typical example of that is forming water. So see if you can figure out this reaction. We have potassium carbonate reacting with barium chloride. Write a balance equation for the double replacement. Go ahead and pause this video here and see if you can write out the reaction without my help. Okay, so we're going to put potassium with chlorine, and we're going to put barium with carbonate. And barium carbonate is insoluble, and so we would need to balance it. Since we have two potassiums as a reactant, I'm going to need a 2 in front of the KCl. And since we have Cl2, that balances that, and that will make everything balanced out. So here in a combustion reaction, I'm asking you to write out from the reaction what the equation is. In anytime you see combustion, you're going to have as one of your reactants oxygen, and your two products should be carbon dioxide and water. So we have to have oxygen, and I'm typically going to give you hydrocarbons, which would mean just hydrogen and carbon, and that will give you just those two products. If I don't give you enough oxygen, then you may see the word incomplete combustion, and that means you would not form carbon dioxide, but you would form carbon monoxide or just carbon, which is soot. Could be additional products. I'm going to give you the complete combustion, however. So when you cook with gas, either in chemistry lab or at home, you use methane plus oxygen gives you CO2 plus water. Pretty straightforward to balance those. Propane would be what you use in the gas grill at home. Butane is what you see inside of a disposable lighter. So when you have something like C8H18, you're likely going to need a 2 in front of that hydrocarbon because of the number of hydrogens. So if you get to a point where you've got everything balanced except for oxygen, we'll need a fraction. Go through and multiply everything else by 2 and then recalculate what you'll need for oxygen, and that will help you balance it. So we can burn other things like magnesium ribbon, and we would get magnesium oxide, or we can burn sulfur and get sulfur dioxide. We could also classify these as combination or synthesis reactions. So I will be very careful when I give you problems like this to make sure you understand whether I'm looking for you to give it to me as a combination or synthesis, or whether it's combustion. If I'm not clear, then I would have to accept either. So here's candle wax, reacts with hydrogen. So what happens to wax as it burns? Well, the wax is actually going to undergo combustion, and we would get this balanced equation. Now, these are really big numbers, and I would not give you something this difficult to balance if we were in class together. But since you'll be taking your tests at home, I may give you something kind of challenging just to see if you can. Don't worry, it won't be terrible. So, ethanol. Now we have a problem when we're burning ethanol. We have oxygen as one of our reactants in two places. We would have it in ethanol, but we would also have it in oxygen. So we have to be careful when we're balancing that we add them together when we're doing that. So here's the equation, or the skeleton equation. Ethanol plus O2 gives me CO2 plus water. And then I have 2 carbons, so I put a 2 in front of CO2. I have 6 hydrogens, so I'm going to put a 3 in front of water. And on the products or right-hand side, I have 7 oxygens, and I need to get 7 on the reactants. So I have 1 in ethanol, and I need 6 more, so I can put a 3 in front of O2, and that would balance. So you've learned how to identify the different types of reactions. You can predict products based on knowing what reaction type it is, and you can tell us how to name it, how to balance it. I think that we've pretty much covered everything in this unit, or this section. So why might you want to classify a chemical reaction? Well, it will help us predict what products will form. So it is a very important skill that you need to be able to do. You'll notice we're at the checkpoints. We're almost done. So we have the 5 general reaction types. These are our key concepts. You should be able to tell us the types of products we get and predict those products. And they're going through each of the 5 types of reactions, and some of them overlap, like a synthesis may be the same as a oxidation or a combustion reaction. And so you have some vocabulary. And our favorite slide, back again. Thank you for watching, and I hope to see you soon.